So in the previous video, we saw how we can define structures for creating the node format, right? Now the next thing to do is to actually allocate a block of memory to create a node, right? So because these structures will have merely defined the format. Okay, they have not created an actual block of memory. So how do you create an actual block of memory? Using memory management function, and the memory management function that we will be using to allocate a node or to allocate a block of memory, which is nothing but a node, or a node is a block of memory, and vice versa. They mean the same thing, right? A node is a block of memory, a block of memory is a node. So in order to allocate memory to create an actual piece of node, which will hold, let's say, all this information at the same place, the data part and the link part, which will hold all this information, two link parts and a data part, we have to use malloc. So what I'll do is I'll show you how you can create a node. Okay, how you can create an actual block of memory. Let's see that. Okay, so I'll keep the structure definitions so that you can follow. Now let's say I write struct node star ptr is same as, so I'm writing it here, okay, because I'm running out of space. So struct node star ptr equal to type of the cast will be the same as the type of the pointer. So this will also be struct node star malloc. How much amount of memory do I want? I want sufficient amount of memory to be able to store the data part as well as the link part. So I'll say malloc size of struct node, right? Now because of this statement, what will happen? Because of this statement, a block of memory will be given to us. Okay, a block of memory will be given to us. And what will be the size of that block? The size of the block will be such that it is large enough to hold values of all the members of the structure. It will be large enough to hold all the members of this structure. So let's say int takes up 2 bytes and my pointer takes up 4 bytes. I get a memory block which is 6 bytes. I get a memory block which is 6 bytes. Now out of these 6 bytes, what you have is, so you have 6 bytes, right? 1, 2, 3, 4, 5, 6. So you have 6 bytes. Here you have 6 bytes of memory. Now each byte will have a unique address. Let's say 100, 101, 102, 103, 104, and 105, right? Now these 6 bytes of memory, right? These 6 bytes of memory, this is one continuous block. Now in this block, there is a demarcation. There is a division. There is a division between the data part and there is a division between the link part. So since the data part takes up 2 bytes, what will happen is the division will take place here, right? The division takes place here. The division takes place here. So in these 2 bytes of memory, what you have is your data part. And in these 4 bytes, what you have is your link part. Now, whatever operations you will be doing on this block of memory will be through the pointer ptr. Remember, malloc returns the address of the first byte. What is the address of the first byte? 100. So ptr now holds a value of 100. So ptr now holds a value of 100 and it is able to point to the first byte of the allocated space. And remember, why do you need a pointer to access this memory block? You need a pointer to access this memory block because this entire memory block does not have a name. Since it does not have a name, you have to access it through a pointer. Now you can access either the data part or the link part. So how do you do that? Let's say you want to give this part a value. So you'll say ptr the member access operator, data, the member that you're trying to access, which is data, and let's say you say 6. So what will happen? The node to which PTR is pointing. Which node is PTR pointing to? PTR is pointing to this node. So the node to which PTR is pointing, take its data part and give it a value of 6. So the node to which PTR is pointing is this. This node has a data part which is this. So give 6 to this part. Okay. And let's say you write a statement PTR arrow link is equal to null. So what will happen? The node to which PTR is pointing. So PTR is pointing to this node. Take its link part. The link part is here and give it a value of null. So this entire 4 bytes will be used to hold the value of null. This holds the value of 6 and this holds the value of null. So this is how you can access the members of a node and give it values according to your choice. Okay, so this is how you actually create a node for a linked list. A node is the basic unit of a linked list. Don't forget that, okay? So all our operations will be based on creating nodes and then linking them together. So in the next video, we'll see how we can link multiple nodes together. So I hope this helps. Thank you so very much.